equation for the circle centered at 0, 0 with a radius of 5. What did we get?
X squared plus 1 squared.
Right? Get y by itself and find the derivative. So we get y squared equals 25 minus x squared. Is that what we got? Square root. So y is plus or minus the square root of 25 minus x squared. I will check it later. Just put it in the turn box.
Or, like an AP test, if those responses get plus or minus.
You still work on number 6?
Yes.
On an AP open response, you would have to put plus or minus. No, definitely not understood, because a square root without a plus or minus is always plus. If you type square root of 9 in your calculator, that answer is 3, and that's it. Okay, any questions so far? Find the derivative. Good. Rewrite first. So I have 1/2, still plus or minus, 25 minus x squared to the negative 1/2 times negative 2x. Y times negative 2x. You could simplify it if you want to. I'm not going to, but you could. Well, I guess I'll show you. If the 2's would cancel, you would get plus or minus x on the top, the square root of 25 minus x squared on the bottom. Any questions so far?
So you can just get rid of the negative and just make it...
Because the plus or minus is going to be plus or minus either way. Do you know what I mean by that? Okay, the tangent line. Remind me how you write a tangent line. How do you write a line in general? Right? Okay, do I have an x and y?
Yes.
Okay. I have a slope. What do you mean I have a slope? Okay, do I have a slope at 3? Or could I find one? How would you find it? Okay, plug in a... What do I plug in for x? 4, right? Wouldn't we plug in 4? You're confused? Which part? The y minus 3? Okay, this equation you have memorized. If you don't, memorize it. So, the y is 3. The x is... No, it's asking for... Yes.
Victoria Anderson.
I do.
She needs to go off.
Okay. You're welcome. You can watch the video. It's asking me to find a tangent line. It says use the derivative to find a tangent line. Speaking of, hey, it would really help if y'all weren't talking so much. Okay. It says use the derivative. How in the world, Devin, is a derivative helpful for this?
The slope.
The slope, right? Isn't the derivative the slope? But I don't want the slope just anywhere. I want the slope at 4. So what do I do with the...
Plug in a 4.
Good. So the derivative, and this is the notation, at x equals 4 is 4 plus or minus 4 over 16. 25 minus 16 is 9. The square root of 9 is 3. Would we agree with that? So positive or negative 4/3. Now this is a pretty challenging question, and I need to go back and refer to the picture. Because there were 2 points at x equals 4. I want the positive. You see how there could have been another tangent line down here, and the slope of it would be different. What is the slope of this one up here? Negative. Everyone agree? It's going down to the right. So that slope is a negative 4/3. So this was a very challenging question. We're actually going to learn a faster, easier way to do this today.
Hey, define
I have a question. The cosine to the power of negative 1. Isn't that 1 for cosine?
It is if it's to the power negative 1. Now, is it on the inside, like is it cosine negative 1 on the inside, or is it parentheses? Okay, then yes, it's 1 over cosine. If it were on the inside, it would be cosine inverse, which would be very different.
well, so did you just plug in more into the
Say that again.
to get 4/3 on the slope? You just plug in a 4,
Yes.
and then that's what you got. You put it. You didn't just figure that out.
No, I put it in right here. I didn't use a calculator, I just used 4. 25 minus 16 is 9. Square root of 9 is 3. Okay. We are going to do a more thorough discussion of this another day, but we're going to do a really quick one today on what a tangent, how to find a tangent line, and then how to find a line that's called a normal line. I really need y'all to get undistracted. Y'all are a little bit distracted today. I know why. I know it's because you got a lot of information last hour, but I only have until 12:10. So for the next 30 minutes, I need your complete and undivided attention. Otherwise, you're not going to get as much knowledge as you need. Okay, I'm going to do a quick discussion of tangent normal lines. Not a long one. We will do a little more with tangent and normal lines after we get the gateway going. It's not on the gateway or the master exam. So, a tangent line is just like any other line. And for any other line, you need what? A slope and a point. So you need an x, a y, and an m. If you have an x, a y, and an m, you can write the equation of a tangent line. The m, which as we know, the derivative is defined as the slope of the tangent line, right? So that's how we'll find m. So let's look at this example. It says find the equation of the line tangent to f of x at x equals 3. Well, what's the x value? 3, because they said so, right? What's the y value?
Plug in 3 in.
Okay, good. Plug 3 in. 9 minus 15, which is negative 6, plus 3 is negative 3.
Negative 3. Find the derivative.
Good. Now I need m, which means I need the derivative.
2 minus 5.
And then I'm going to plug in 3 to that. Remember, m is a number. One of the biggest mistakes people make here is trying to not put a number. But m is a number. It's an actual slope. So I'm going to do f prime of 3, which is 1. Good. So y plus 3 equals 1 times x minus 3 is my tangent line. Where, no, it's x minus 3. Only to match multiple choice. Otherwise, no. If it's open response, this is a line, I'm good.
Is this all we're learning today?
No. Did someone say Miss King? Okay.
3.
All right. A normal line is a little different, and in calculus we don't do a lot of applications of normal lines. It's actually a physics reason we even do normal lines. Normal lines give you a perpendicular line to a tangent line, and in physics it's an opposing force. Those of you who are in physics may care more. And in calculus, we actually hardly ever touch normal lines except when they say find a normal line, and then we do because they said so. But in physics, they have a real-world application with opposing forces. So the normal line is, for your knowledge, just perpendicular to the tangent line. Notice this is the same equation we had earlier, right? I want the normal line at 3. Well, the x value is still 3. The y value is still -3.
-1.
But the m is different. The m is the opposite reciprocal because it's perpendicular on it, so -1. Opposite reciprocal. Flip it and make it negative. Devin, you can't sleep in here. It's against rules. I'm pregnant and tired. I'm awake. You have to be awake too.
Friday Night Lights.
Okay, any questions? All right. What we are going to learn today, the big new thing for today, is called implicit differentiation. It will give us a shortcut to the bell ringer. Y'all thought the bell ringer was pretty tricky?
Oh, yeah.
We're going to simplify that derivative quite a bit. To do that, we need to talk about what's called implicit differentiation. There are two types of ways you can define an equation or a function. You can do it explicitly, where you have y equals a function. That is called an explicit definition of a function. You explicitly said y equals this. Or it can be implicitly defined, where it's got x's and y's mixed together on both sides of the equation. The circle equation is implicitly defined, right? X squared plus y squared equals 25. So if we could work with it in that format, it could make our lives a little easier, especially if the equation got harder, like an ellipse equation maybe, or something more difficult to solve. So we're going to want to try to figure out how to take derivatives when y is not by itself. And so the first thing I want to do is kind of back step and talk about derivatives with variables that aren't x. The first thing we have is the derivative with respect to x of x to the fourth. And this is a question you've been asked a million times, and what is the answer? 4x to the third. And that's it. However, this asks a very different question, because it says the derivative with respect to x of y to the fourth. Do I know what y is? Y could be anything, right? Could be 3x minus 7. Could be cosine of x. I don't know what it is. Could be anything. It's like you know, on your chain or on your calculus helper. You know all those u's. So what do you have to do when you take the derivative of this?
1/4 x to the negative
No.
3/4. What's going on?
Chain rule. You have to do chain rule. Why? Because what's y?
Y letter.
Okay. But it's probably something in terms of x, right? So say y is 3x minus 2. Then if 3x minus 2 is in here, what do you have to do? You have to do the chain rule. You have to multiply by the derivative of the inside, which is y prime. Now you might also, this might explain, some of you have asked some questions about your calculus helper. This might explain why your calculus helper has to have u primes on every step. Because it says the derivative with respect to x, but then it has a u. Well, if it has a u, that means you have to do a chain rule, because I don't know what u is, right? Okay?
This doesn't make sense.
So y is something. It's not an x. If I'm doing the derivative with respect to x, y is something in terms of x. So pretend it's 3x minus 2. So how would you take the derivative of 3x minus 2 to the 4th? No, you wouldn't.
No, I can move the 4 to the front.
Leave the inside alone to the 3rd power times the derivative of the inside. Okay. I better erase that 3x minus 2. That will confuse someone on notes. Okay, let's look at this one. And I'm going to use different notation on this one just so you get familiar with both notations. There's y prime notation's great, but we could also use other notations. So I'm going to show you another one. How do you take the derivative of just plain x?
1.
It's 1. Do you need an x prime?
No.
No, because if you did, you would write something that looks like dx over dx, which is just 1. The derivative of x with respect to x is just 1. What about 5 times y? What's the derivative? 5 times whatever the derivative of y is. So 2 ways you can write that. You can write dy dx, or you can write 1 plus 5y prime. Those mean the same thing. Now, mental note. I use this notation here for a reason, to show you the difference between the x and the y. If I were to have written that notation for the x, would you agree it would have been dx over dx? Change in x over change in x. And what would that divide to give you?
1.
1. So you see why you don't need it with x? But you do need it with y, because I'm taking the derivative with respect to x. So the denominator is change in x. Does that make sense? I'll leave this out. All right. Remind me where I put it. Okay, let's look at the next one. What rule do I need on the next one? Product rule. Does everyone agree? Let's see why I made you do number 56 and 58. It was kind of prepping you for something like this, right? Okay, so left, d right. What's the derivative of y? The derivative of y, right? That's what it is. Y prime or dy dx, either way. Plus right times the derivative of the left. Good. And you can write that in either order, Paxton. It doesn't matter. So moral of this story. If you take a derivative of anything other than x, you have to have a prime. Now, I want to revisit the bell ringer. The bell ringer wasn't terrible, but you had to solve for y and you had the plus or minus. It was a little strange. Instead of getting y by itself, I'm just going to take the derivative as it sits. As you know with equations, you can usually do an operator as long as you do it on both sides, right? So I'm just going to take the derivative of everything, d dx of everything. What would the derivative of x squared be? What would the derivative of y squared be? 2y times y prime or dy dx. It doesn't matter which way you do that, as long as you use one of the two notations. We're done. I would suggest, if you are a sloppy handwriter, that you use dy dx, because the little y primes get lost. If you're neat, go use y primes, either way. But you probably know the difference in yourself. I prefer, when I work, I use dy dx because I lose y primes. I think they're exponents and lose them. So I use dy dx, but other than that, it doesn't make any difference. Some of you have perfect handwriting and would never lose anything. What is the derivative of 25? A lot of people mess that up. They bring the 25 down. Don't forget, you take the derivative of everything. See? Now, if I wanted a slope, I could get dy dx by itself. Oops. Lost my dy dx. I still tried to lose it, and I even wrote it out wrong. Negative 2x. And I could divide by 2y.
Give you negative x.
So I get dy dx is negative 2x over 2y. Or negative x over y. Now, what would the derivative be at the point 43 that we had earlier? Negative 4/3. Do I even have to make the decision on the plus or minus this time? No, it took care of it for me because it knows what the y value is. So, this is a faster way to do a derivative if y is not already by itself. Now, it is defined a little differently. It has an x and a y in the definition, and that's okay. Okay, so summary of how to do it. The second way was a lot easier. It tells you more about the derivative because it has an x and a y. The steps are, 1, imagine the relationship defines y as some function of x. So that was what, remember when I said, Drew, pretend that y is 3x minus 2. We're pretending. That's what, step 1 is to pretend y is a function of x. Then take the derivative of both sides. Make sure every time there's a y, you do a chain rule. You do a y prime. Every time there's a y that you do a derivative of, you do a chain rule. And I want you to put in parentheses beside number 1. Don't forget to do product rules as well. If you have x sitting next to a y, x, y multiply together, make sure you use a product rule. So be careful with product rule and chain rule. Collect all the y prime terms on one side of the equation, factor out a y prime, and then we will solve for y prime. If the question asks about a specific point, you can plug it in. Now, you may not have been on board with me on the last slide. You may have thought, the bell ringer wasn't that hard. I could just solve for y. What do you think now? This one is possible to solve for y. Yucky, but possible. There are some that are impossible. I could make up an equation, or an equation that you could not solve for y. So this is a necessary. It's not just to make some things easier, though it does. It's also a requirement that we can do it. Okay, so let's start. We have x squared y cubed minus 6 equals 5y cubed plus x. And I'm going to take the derivative of everything. The derivative with respect to x of everything. And by the way, can you do the whole mastery exam now? The number 4 that you couldn't do, now you can. This is multiplied together, agreed? So what do I need to do on that first piece?
Product.
X is left, you're welcome. D right. Miller. That paper needs to not be blank next time I look at it. 3y squared times what? Times y prime. Y times y prime. Because I took a derivative of something with a y in it. Right? Anytime you do that, you have to do a chain rule.
Is it automatically y prime no matter what?
Yeah, or dy dx, whichever notation you prefer. Plus, right, d left. What is d left? 2x. Do I need a y prime on this term? Why not? I didn't do a derivative of y. So I don't put a y prime there. Okay, all of this blue part is the derivative of that product. So when you come to products, be careful, they take some work.
Can you move it up?
Yes. You're welcome.
Can you explain one more time why we multiply by y prime?
So y is some function of x, like 3x minus 2. So now, that being said,
That's the inside.
that's the inside part. And so I don't know what y is, but it is some function of x. And so I always have to do a chain rule when I come to a y.
Just plug in a x plus 1 anywhere you see your y.
And envision it being, so that's that step 0 up there. Imagine y being something with x. Devin. It's going to kill you if you sleep through this. Okay. The derivative of 6. It helps if you write. You will not fall asleep as easy if you're writing. No, pick your pencil up and write. Right now. Do it.
Right. Let's do it. Right now.
Yes. What is the derivative of 6? 0. So I could put minus 0. Or I can not put anything. What about 5y cubed? 15y squared times y prime. Why do I need a y prime? Because derivative of y we had something other than x, so I need a y prime. Plus 1. This was plus. And the derivative of x is 1. Hey, step, what was it, 3? I think it was step 3. Collect all the y prime terms on one side of the equation. So I'm going to underline those in green. This was a y prime term, and this was a y prime term. So I'm going to get all of those on one side of the equation. Doesn't matter which side, I don't care, but one side of the equation. So I have 3x squared y prime minus 15y squared y prime. So the green ones on the same side of the equation. So to move that, I had to subtract. Okay, I put the 3 in front. You can leave it in the middle if you want.
Oh,
you can leave it in the middle if you want. Okay, any questions so far? Subtracted the 15y squared y prime over. And then the purple parts of the equation. 1 minus 2xy cubed. The purple part. You will get really fast at this step. I'm just going to move them around, put negatives in front, you know what I mean. In fact, you're probably even going to combine that step with the next step, and that's factoring out the y prime. It said to factor out y prime. If I need to get y prime by itself, then I need it factored out. Do you see what I mean by you could probably do that in the same step as you getting the y primes on one side of the equation? Probably just write y prime times, parentheses, leave it. But we will shortcut later. We'll go slow for now. You're grown-ups now. Grown-up math students.
Oh, they used to divide it up.
And divide by that other part. So dy dx, and if you had used the dy dx notation, you would have dy dx here. It doesn't make any difference to me which one you have. Dy dx or y prime is that value. That was our goal. We are done. Find the derivative.
Wait, we already found the derivative way up there. Can we stop way up there?
It always wants dy dx or y prime.
Why do you have to get the...
I do still want y prime by itself, because they will always make you do that part. But you don't have to simplify the fraction, like factor or any, just get y prime by itself.
How do you do
Ask me later.
I don't remember what it is.
Okay, let's look at this one. Use your calculus helper. Ask me about it after class. We still have some implicit to learn. Or practice. Okay, so we're gonna do some more examples. So we did one, but we could use some more. So I want you to try the top one. I want to see yours. See it. Start on that top of that pile. Right in. Depends. So on that one, it's just a plain y. So the derivative of a plain y is just not if it were y squared. That's 2y to the first time.
Oh, I thought it was wrong.
Yeah. I see you do this. Problem on the board. This is not due to mine.
Oh.
And Alec, did you get minutes? 3 minutes. You did. Okay, let's look at this one. This will probably be the last example we do today. We will do more examples tomorrow. You need to see more examples. The only thing on your homework that you cannot do yet is when it asks you to find the second derivative of something. Don't try that. You don't know how to do second derivative implicitly yet. We will talk about that tomorrow.
So where is that?
This is implicit, yes. Yeah, that's just normal. Like when it's y equals, that's explicit. And implicit is when it's not y equals. Okay, left d right plus right d left equals what? Okay. X, y prime equals negative y. Y prime equals negative y over x. Okay, any questions about that one? Okay. Okay, and we will finish this tomorrow. What I would recommend, chain rule homework has to be done by tomorrow. And then I would also recommend doing that gateway or the mastery exam. I would do that tonight. This is not due until Monday, so you can do some of it, but there's some you can't do, so we did not. Just the worksheets now.